So, area of a triangle. Now, it's not just something we're going to review. I know you know how to find the area of triangles. I know you've learned it before. We're going to find the area of triangles a bit differently, using trigonometry, sine and cosine and such. And then an extension of what we do with the area leads us into what's called the law of sines. It's a way. Do you guys remember 3 or 4 weeks ago we did a trig review where you had to find the missing side of a triangle or the missing angle of a triangle? Does that sound familiar? Look, let me show you.
Sounds like you don't remember. Like if I gave you this triangle, hey, your X is gone. And I told you to find the missing side. Does this sound familiar now?
Well, they stay in here.
How'd you do it? It was only 3 or 4 weeks ago, and that was even reviewed from last year. So this is like the 3rd time you've seen this now. At some point, it needs to start sticking. Would we use sine, cosine, or tangents? Cosine, right? Because this side is adjacent and this side is the hypotenuse. By the number of responses I'm getting, it's like you guys have never seen this before. By raise of hands, I want to see some kind of acknowledgement here. By raise of hands, does this look familiar?
Yes. Well, there's a triangle numbering X.
Okay. Raise your hand again if the word cosine sounds familiar. So I know at least your brains are turned on.
Yeah.
Okay?
You know it is.
Now, why won't this work? Why is that incorrect? Why is that incorrect? What's the definition of sine?
Opposite over hypotenuse.
Opposite over hypotenuse. We don't have the opposite length. We have the adjacent, so that has to be cosine. So we did a few problems like this on a worksheet. We also did problems where you had to find an angle, like if I had 4 and 9 and a symbol figure right there.
It's not one of the weird perfect triangles.
That's not one of the special triangles.
Never mind
Which trig function makes sense here?
Tangent. Yeah.
So you do tangent of theta equals 4 ninths, and then how would you get theta by itself?
You would do the inverse.
Inverse tangent. By raise of hands, does that sound familiar?
I would just mention that.
We've done a ton of this stuff. Okay. The problem is, I guess it's not really a problem, but the thing you have to realize, those problems only work because we have a right angle. Yes? If I had drawn this kind of a triangle and asked you to find this length right here, if this were 20 degrees, you see how this is a little bit different of a problem? We can't use any of that stuff we learned because this is not a right triangle. This is a right triangle, this is not a right triangle. You understanding now?
Yeah.
That's why we have to have today's lesson using what's called the law of sines. You can figure out what x equals. But it's a different process. What's that? So it involves, only sine. So let's get back to this. We'll get to that here in a second. Do these sound familiar? Side, angle, side, 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 angle, side, angle, 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 side. The reason you have to know these is there's another law that we'll learn on Friday called the law of cosines. And depending on which one of these cases you have, will determine which law you use. If it's side, 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 for example, you have to use law of cosines. Or if it's angle, side, angle, or angle, angle, side, you can use law of sines. So you have to be able to distinguish. So just for the sake of practice, I know you've done this before, and I hope it's easy because it is pretty easy. Just draw the triangles and don't yell anything out, but I just want you to label what each one of them is. So would this be like side, 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 for example, or angle, side, angle? Whatever you think it is, just write it underneath. Don't yell it out and spoil the surprise. But this is an important skill. You have to know what you're dealing with.
42 degrees.
Oh, that's 42. Ooh, that's a very important drawing, too.
It's 42 degrees.
So brutally honest. Away from the board. Of course you don't.
So Brian, hop on up here. You're going to help me out with one of these. The first triangle there on the left. Underneath it, I want you to write, the sides. What case do you think that one is? What do you guys think?
Yeah.
Thumbs up, thumbs down? Or undecided, maybe? That's good. Side, angle, side. Side, angle, side. Okay. Now, again, I hope that wasn't a hard decision to make, but the reason it has to be side, angle, side, these two sides come together and form a 42-degree angle, yes? So would you say this angle is between the two sides? The phrasing there is called the included angle. I'm going to be talking using that phrase later on. It's called the included angle. This one here today has been giving my students some trouble. I don't know why. Let's see, we had a guy, we need a lady coming up. Anybody want to take a stab at it? I don't know why. This one's been giving us some trouble. Avery, what do you think? Want to come up and give it a try? Thank you.
Just right off to the side leg right here.
So she's saying, what do you, angle side? What are we thinking? We need a consensus here. It is angle side. Thank you. You guys got it. Here's the confusion though.
Some of my students in my other classes were writing this, and they were pretty convinced. They were pretty convinced it was angle, side, angle.
There's an angle.
Okay?
Side.
Because
There's also an angle.
we do have two angles on our side, right? And here we have two angles on a side. So what does it matter if it's angle, side, or angle, side, angle? It matters a lot. The way that you've written the S here, that means the side should come between the two angles.
Yeah.
Okay? This right now is the side that's between the two angles.
Whoa. What the?
Cool.
Trippy. Trippy good for a single line.
Let's get rid of that.
Because you're so trying.
Yeah, there we go. This side right here is the side that's between the two angles. But I wrote 9 up here. It's not between the two angles, so it has to be this.
So if the 9 was on the side between the two angles, what if
But if I wrote 9 right there, then we would have, you see the difference? It's really important that you can see this because that determines which law you use, whether it's law of sines or law of cosines. At any rate, the way I had originally drawn it, angle side. What if I put the 9 right here? Is it still angle side? Still angle side. Okay. You. This is another review question, or at least I hope this is review. It should be. Try that problem. Should be review. This does depend on the fact that you can remember the area formula. If you don't use it all the time, it might be pretty easy to forget. It's not a super hard formula though. Does anybody remember it? 1/2. 1/2 base times the height. You've heard it before, I'm assuming. It's late elementary, early junior high formula.
The area of a triangle is 1/2 the base times the height. So this would be 1/2 times 11 times 4 which is just 22. There's something you need to add on to this, though. I mean, we didn't do anything wrong. That is the area. The area is 22. You need to be aware of something. This formula only works if the height, ooh, here's a big word. I don't want your brains to explode. Perpendicular.
Oh, geez.
We okay with that word? You need to get out of dictionary. Perpendicular means
Crosses at 90 degrees.
means right angle, means crosses it at a 90 degree. If the height is perpendicular to the base, such as this picture here, this height of 4 is perpendicular to the base of 11. You guys understand what I'm talking about? If I had, let me get a blank screen here. If I had given you this triangle, and said the base was, I don't know, 84, and I drew a dotted line here and said this was 16, could you use the same area formula, 1/2 base times height? This is the height. Is it perpendicular to the base?
The height is, yeah.
What if I said that this side length here was 16? Could you use the same area formula? No. You see the problem? And this is what we're going to be dealing with today. We're going to be given triangles and we don't necessarily know the height. But we still have to find the area. There's a different way of doing it. It involves trigonometry. So let's consider this triangle. Now, if I'm calling this angle A, hopefully you learned this last year. If this is angle A, you have to call this over here side A. Do you remember this? With a lowercase letter? If this is angle C, then across from that has to be side C. And then this has to be side B. If I told you that B was 10 and C was, I don't know, 6, could you use those two numbers to find the area? If we knew B and C, could you find the area using this formula, 1/2 base times height? This is not the height of the triangle. So area equals 1/2 base times height. But we don't know the height. That's a problem. So do this. Start at B. Do a dotted line straight down to side B. And we're going to call that H because it's the height. We don't know what it is, but it's the height. And make sure you represent it with a right angle. Now, I want you to do this just to visually make this easier to understand. Do that. I want you just to look at that smaller right triangle that we've created. Quite a few students have been able to answer this question. It surprised me. I thought I would stump them. but I don't know, got some pretty clever students in here. You might be able to answer this. If I told you what angle A was, like 40 degrees or something like that, if I told you the measure of angle A, how would you find H? Assuming you knew all three sides. Let's assume you knew all three sides and you knew the measure of angle A. How would you find H? And it's not a trick question or anything. You know the answer. And we've got plenty of time. Say that louder. Why? Did you guys hear that? I told you that we know all three sides. We just don't know H. But we also know an angle A. So H, in relation to angle A, would you call this an opposite, an adjacent, or a hypotenuse? Opposite, yes?
Yes.
What would you call side C? Well, what are we describing? Opposite, hypotenuse? You guys know this stuff. This is not brand new, and this is not way above your level either. This is on your level. This is stuff you ought to be able to come up with. What are we describing? Opposite and hypotenuse. It's the sine. Okay? If we took the sine of angle A, that's equal to H over C. This is not just a fun activity I'm trying to get you guys to try to appreciate. Okay? We have to find the area. But all we were given is angles and sides. We didn't know the height. So this is a way we can find the height so we can use this formula. You guys following? Well, right now the height is being divided by C. So how do we undo that? Multiply that side by C, multiply that side by C. C's cancel, so now we have the height is equal to C times the sine of A. Here's what I'm going to do though, or this is what you guys need to do. H equals C times the sine of A, yes or no? This H is the same as this H, yes or no? So I'm going to take this value right here and replace it up into that formula and create a new formula. A equals 1/2 B. And instead of H, I'm going to use this value of H. C times the sine of A. This is a variation of the area formula that uses trigonometry. So if you don't happen to know the height of a triangle, that doesn't necessarily mean you can't find its area. If you know an angle measure and the two sides that form that angle, you can find the area using this formula. Okay? Now I just said something that you probably didn't think was that important. Take a look at these two sides, B and C, and then consider the angle, angle A. What's the relationship between side BC and angle A? This is pretty important that you guys are listening here.
I'm going to say that loud. What's the relationship between sides BC and angle A? From royalty. Sure.
Okay, so we just have formula with this split and
Alright, anyway, back to this. Jordan, I think you were about to answer. What's the relationship between side BC and angle A? Side C, side B, angle A. Angle A is between side B and C. Do you guys agree? Yeah. That has to happen to use this formula. You have to have two sides and the angle in between them. Okay? You have to have two sides and the angle in between them. You guys following?
Yes.
So I've written the formula 3 different ways. It's not that you have to memorize 3 formulas. I don't want you guys freaking out about remembering 3 formulas. It's just, it depends on where A, B, and C are. It's a pretty good box. So for example, if you have side BC, you have to have angle A. Or if you have side AB, you have to have angle C. Or if you have side AC, you have to have angle B. The point is, you have to have two sides and the angle in between them. And because that idea is so important, you need to write that down.
With the little star.
Yep. I wrote it this way. You have to have two sides and the included angle. All that means it's the angle between the two sides. The included angle. It's a really very simple formula too. As long as you can recognize that you have two sides and the angle between them, just plug it into this formula. So, get your books open.
We have books.
You've got books.
Down it. For the first time ever. Such as life. Jordan, can you give me?
Page 467. You see how it says problem 1? Got it right at the top.
Yeah.
I want you to do the problem 1. Got it. Page 467.
67.
I want you to do the problem 1. Got it.
It's a word problem.
Well, actually, you know what? Let's do this one together, and then I'll have you do one on your own. Let's do this one together. Now, the thing about this one, it just gives you a bunch of words, and you gotta read them. There's no picture. Draw your own dang picture. If there's not one given, draw it. And it doesn't matter what the size or the shape of the triangle. So here was my idea of a triangle.
Perfection.
Doesn't have to look exactly like that. It could look like anything. The point is, it's probably doesn't. No, it's not a right triangle. The point is, it's probably going to be easier if you can draw this out. Really important, though, is where you label. Didn't they say that the angle is in between the sides? Didn't they say that in there? So wherever you put the sides, you've got to make sure your angle is between them. Okay?
And the question is to find the area. And if you're thinking, well, crap, which one of these 3 formulas do we use? Is it BC sine A or AB sine C? The answer is it doesn't matter. Okay? The only thing that matters is, do you have two sides and an included angle? Yes or no? You have two sides here and the angle between them, yeah? So it doesn't matter which one's A, B, or C. The formula says you take 1/2 and then you multiply the two sides, 12 times 15, and then you take the sine of the angle between them.
Correct.
Doesn't matter which one's A, B, or C.
You just push all that into the calculator.
Yeah, and then it's just a calculator problem. So it's 1/2. I'm just going to do 0.5 rather than 1/2. Times 12 times 15 times the sine of 24.
Wait,
You don't have to. I did 0.5 times 12 times 15 sine 24. Just curious, did anybody's calculator not tell them 36.6? Why is that?
good question. You're in the wrong mode.
You're probably in radian mode. We've been doing a lot of radians recently, guys, and these are degrees.
It'd be nice if you could tell us that at the beginning. Maybe not just think about it.
It's something that you need to think about. So if you change your mode back to degree mode, then it should give you 36.6.
So the area is 36.6 inches squared.
Does it have to be squared?
Yep.
Why?
Because an area is a two-dimensional measurement. It's length and width, pretty much, so it has to be squared.
Three-dimensional.
Volume.
Okay.
So, any questions on that? Try the number, the A practice just beneath it. Try that one on your own. See if you can do that one. The A practice number 1. See if you can do that one.
Oh, great.
Yo. Do some homework. I know you've got some. Good. Mm-hmm. Barely though.
Mental placement. Thank you. This is all.
All right. Let's see. Who's gonna be? Nobody's making eye contact. Don't look at him.
No, you have to look at them, because if you don't, they don't come on.
It's like, all right, who wants to say the prayer now? That's all I know.
You have to look at them. In school, you have to look at them, because then they think they know.
You ready? Or am I gonna choose? You choose or I choose. You want to do it?
Yeah.
I didn't avoid eye contact with you. I was looking right at it. Where's my favorite? I like it. The keys to start off again.
Yeah, right down the steps. We got a brave volunteer. No, he did this. He wanted to.
It's more of like voluntold.
He wanted the blessings. One half.
Hello.
So, I have a question. Does the angle always go after a sine, and do the sides always go in the middle? Okay.
You're good so far.
Can I put in my calculator?
18.6.
Would you have to put C in since there was a C in?
One. Yeah. Let's change that to 8.7 if we round up. Ooh, look at that. He got the eraser in there. 18.7 centimeters squared. That's as good as it gets. Nice job. Questions? Okay, so just to wrap this up, we've been talking about area of triangles. The formula you guys learned in junior high only works if the height is perpendicular to the base, right?
Right.
Okay, we've just practiced another formula where all you have to have is two sides and an angle in between them. Doesn't matter if the height is perpendicular. You don't even have to have a height. Right?
Yes, height.
Okay. We need to talk about law of sine. Stand up, though, you guys. Stand up.
So, you don't really need to write this down because we talked about it right at the beginning, but I want to quickly go over this problem just to lead into what we're going to talk about. If I ask you to find this missing side, that you would use tangent, cosine, sine, which one? Sine, because this is opposite over sine 34 equals x over 15. And then you multiply both sides by 15 and you get x equals 15 times the sine of 34, right? This only works because this is a right triangle. Remember we talked about that? That stuff you guys learned last year was called right triangle trigonometry. It only works if there's a 90-degree angle in there somewhere. But what you're going to see in your homework would be something like this. So draw this one. This is a 32-degree angle.
That's a 39-degree angle.
Not necessarily, no. If you don't, usually they would do something like this. And then point to the angle. You can do it like that.
Or you can just draw a V.
Too small of a triangle. So, this is not a right triangle. This whole method right here is no good for this triangle. You guys agree?
Yeah.
Because I said so. So you better agree.
I don't care if you write this next part down or not, but part of secondary 3 is I'm supposed to show you where this law of sines comes from. So 1/2 BC times the sine of A. Wasn't this the area formula that you guys just wrote down? Wasn't there another area formula? 1/2, let's say AC times the sine of B. Wasn't that another version of it? Since both versions could work on the same triangle, they both give you the same area. They're equal to each other. If I divided this side by 1/2 B, wouldn't I have to divide this side? Well, actually, I'm going to divide it by 1/2 C. And I'm going to divide this side by 1/2 C. If I divide it by 1/2 C, then those just cancel on both sides. And I'm left with B times the sine of A is equal to A times the sine of B.
You want us to write that down?
You guys still with me?
Yeah.
I'll tell you when I want you to start writing. If I divided this side by AB and this side by AB, then here the B's would cancel and here the A's would cancel. So I'd be left with the sine of angle A over little a equals the sine of big B over little b. You guys with me still?
Yeah.
This is the law of sines. That's what you need to write down. And it actually would have worked with angle C as well. So the law of sines is, try to distinguish in your notes that these are capital letters up here and these are lowercase letters. That's important. This is what I want you to write. This is the law of sines.
Also put a square around it too.
Yours needs to be an octagon. Yeah.
Not correct.
Now you're probably not ever going to have to reproduce this derivation, but just so you know, this wasn't just some random thing. It came straight from those two area formulas we were talking about. This also is important that you write. The law of sines can be used to find missing sides and angles of triangles that are not right triangles. Because we can't discriminate in this class. We can't give right triangles special treatment.
Pretty sure we do.
There is a limitation to the law of sines. However, it only works if you have an angle-angle-side triangle or a side-to-side angle triangle. And I suppose it could work with an angle-side angle triangle. I don't know if you'll see that on your homework or not, but so it doesn't work for every single triangle. If you have side, 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 for example, yeah, law of sines is no good.
Right.
There's something called the law of cosines. We'll learn about that next time. Law of cosines. You guys got this written down? You ready to move on? So, going back to the triangle I had you draw, first of all, we probably should decide if we can even use law of sines on this triangle. Look at the given information. So this angle, and that side. What kind of triangle is this? Is it side, angle, side, angle, side, angle, side, side, side? Come on. What is this? Using just the given information. It's angle, angle, side. So yes, no on law of sines. Yeah, we can use law of sines. Well, just with the given information. Not counting this. Just with the given information, it's going to be angle, angle, side. So, yeah, this is angle, angle, side. The law of sines is not difficult to use. Okay? The thing is, you're not going to use all three pieces at the same time. You're going to choose two pieces and use only two pieces. Okay? And sometimes the triangle will be labeled for you with A, B, and C, so it's an easy choice. If the triangle is not labeled like this one, then label it however you want. You can put A here, for example, and you can put B here, and you can put C here, and then just make your own labels. Now, depending on where you put the angles, that determines where your sides are. If this is angle A, then this is going to be little a over here. If this is angle B, this is little b. And if this is angle C, then this has to be side C. I could have switched this up and put angle A up here and angle B over here. Doesn't matter. We would have eventually gotten to the same. But if I choose to label it this way, now you got to decide what you're looking for. I know it says we're looking for X, but according to my labels, aren't we looking for side A? Because it's across from angle A. Yeah. So if we're looking for side A, that means definitely we're going to choose this piece right here, sine of. Because I'm not asking you to find side B. I'm asking you to find side A. That's where the X is.
So the question is that.
Yeah. So we're going to use sine A over little a. But you have to use one more piece, and you have to think about what you've been given. We've been given angle C and side C, so we're going to use this piece of the law of sines as well. You guys with me? Why are we not using anything with B?
Do we know angle B? Do we know side B? So we wouldn't use any of them because we don't know either of those.
Okay. Now, remind me again what we're even looking for. And what are we calling X? Side A, right? Just a suggestion here. You don't have to do it this way, but I think it would be easier if you did. Whatever value you're trying to find, you guys with me here? Whatever value you're trying to find, it's always easier if it were at the top of a fraction and not the bottom. Right now we're looking for A and it's at the bottom. That's not necessarily the easiest thing to do. So I'm going to flip both of these fractions upside down. It's still the same ratio. I just find for most students it's easier when whatever you're looking for is on top of a fraction. Now fill in what you know. We don't know little a, so just leave that as little a, but we know everything else. Angle A was 32 degrees. Side C was 40. And angle C is 39. So all we're doing is filling in the information that we've been given. We're not having to come up with anything on our own yet. All we really had to come up with is which parts of the law of sines were we using, and that was not a very hard choice. Now, we're looking for side A. Yes?
Yeah.
Right now it's being divided by the sine of 32. So how do you undo division? So you've got to multiply this side by the sine of 32, and then multiply over here by the sine of 32. If you multiply the sine of 32 and it's being divided by the sine of 32, those cancel each other out, and you're left with A equals 40 times the sine of 32 all over the sine of 39. And this is a calculator problem from here on out. A lot of students make the mistake of thinking that they're better with their calculator than they really are. I probably wouldn't type this whole thing in all at once if I were you. Okay? A lot of ways you can make some typing mistakes, so I would just do the numerator first. 40 times the sine of 32, then hit enter. Now, I would hope that a lot of you have discovered this by now since you're in 11th grade, but with these graphing calculators, it stores the previous answer. So if I were to hit the divide button, it doesn't just say divide, it takes the previous answer and then divides that. Right? So instead of copying all those numbers and retyping them, just hit divide and it copies it for you. Answer divided by sine of 39 is 33.7.
There you go.
So that's the length of the missing side, 33.7. So the problem 2 got it. Where is that?
Let's do that one together. So it's 468. Oh, they didn't give us a picture.
So it says in triangle KLM, measure of angle K is 120, measure of angle M is 50, and ML equals 35 yards. What is KL? Well, since they haven't given you a triangle, just draw your own triangle. Doesn't matter the size or the shape. And we know the letters have to be K, L, and M. And it says the measure of angle K is 120. Now, obviously, I didn't draw my triangle here according to scale. Doesn't matter. Angle M is 50. And ML... ML means the distance from M to L. So if you start at M and go to L, it's 35. They're asking what's KL. So if you put an X over here for KL, now if the K's and the M's and the L's are confusing you, just replace them with A, B's, and C's. It doesn't matter. Now the way I've written this, if your picture looks anything like mine, the X is over here. It's across from angle B. That means we're trying to find side B. So I'm going to use B over sine of capital B. That's the first part of the law of sines we're going to use. Now we have to decide on the other part.
Remember, we only used 2 of the parts. We've been given the way I've labeled it, angle A and the side across from it. Side A.
So those would be the other 2 parts we ought to use. Side A is 35. And then that's divided by the sine of angle A, which is 120. I'm going to replace capital B actually with 50. Capital B is 50 degrees. This is A. So the form I'm using is B over sine B is equal to A over sine A. Those are the pieces I'm using here. This is just like the last problem. How do you get B by itself? Multiply by sine of 50 on both sides. So B equals 35 times the sine of 50 over the sine of 120. Again, I'd break this up into 2 different things. 35 sine 50, figure out what that is. Then divide that by sine of 120. 30.959, if we round up, we should probably call that 31. $31 yards.
Why don't you guys try the A practice number 4, the 4th one. A practice, it's on page 468. A practice number 4. Telling yourself, yeah, I got this, after watching somebody else do it is one thing. Actually doing it on your own on a piece of paper, that's a different thing entirely.
Just we don't have too much time. Take a little bit of time and see what your neighbor got.
1.4.
This is just a coincidence. We're not always looking for side A. It just happens that on all 3 of these, it looks like we are. But, so I'm going to use little a over sine 48 equals little b, which is 10, over the sine of capital B, which is 93. If you multiply it by sine of 48 on both sides, you get 7.4. What's that? You could, yeah. You could.
You could use the fish.
No!
That's the fish, though. I love the fish. The fish is the hero. The fish is
Fish is gone. Fish is dead.
Fish, right. Fish is gone before now.
Oh, man, you guys. This has been a pretty long discussion, hasn't it?
Yeah.
Guess what?
Love the fish. It's not done yet.
It's not quite over. Here's what. The law of sines can be used to find missing sides and angles. We haven't found any missing angles.
It's just a third page.
Sorry, I know this is a pretty long lesson, but it is what it is. So here's how you can use law of sines to find a missing angle.
You just not show us or tell us that you did.
No, unless you want to fail it on the test.
Do you like the fancy inverse
You guys are what, 17, 18 years old, right? You guys would rather be treated as adults than children, right? If you want to be treated as adults, you got to act like it. Sometimes adults have to do things they don't want to do. Sometimes adults have to do things they don't like doing. Not doing something because I don't like it. That's pretty childish. You guys are children, aren't you?
Yeah, that's the goal.
You guys aren't children, you're adults. Or you're becoming adults. If you want to be treated like them, you've got to act like them. I don't care if you like this stuff or not. It's not my job to get you to like it. You either like it or you don't. And your job is to suck it up and be adults about it and learn it anyway. Let me get off my soapbox now. Jeez. It's no different. There is one difference at the end. Now, I'm asking you to find angle A. Only way that can work is if you know the side across from angle A. So it's 7. Who can tell me why all of a sudden I flipped the fractions upside down? Why is it sine A over little a now? Of course I can. I just did it. But why did I do it? Now the angle is on the top. You remember I mentioned right at the beginning that whatever it is you're trying to find, it's always easier if you put it on the top of the fraction. Remember that? It is always easier that way. So, we don't know the measure of angle A, so I'm just going to keep that sine of capital A. Now, little a, that's just 7. We know capital B, that's 110. Little b is 9.
Basically the same thing.
Pretty close. We've got to multiply by 7 because it's being divided by 7, and multiplying is the opposite. So the 7's here cancel out. So now we have the sine of A is equal to 7 times the sine of 110 all over 9. Well, not yet, not yet, not yet. I've had some pretty strange, well, let me take that back. I've had some different sorts, interesting is a good word, interesting suggestions regarding what to do now. I know you guys know the answer. If I were to put a square root over A, would anybody in here tell me to divide by a square root to get rid of the square root? No, at least you shouldn't. I hope you wouldn't. What would get rid of a square root?
Multiply by square.
Squaring, because those are opposites, right?
Yeah.
The reason I'm bringing this up is this suggestion has come up from time to time. Well, just divide by sign.
Inverse sign.
You can't divide by sign to get rid of sign. That's like dividing by a square root to get rid of a square root. That doesn't work. What gets rid of a sign?
Inverse sign.
Inverse sign. On both sides.
Just get rid of the inverse. That's it.
The inverse gets rid of the sign on the left side.
Just get rid of the sign on the right side too.
There was, well, no, because the 7 is in the way.
Now you're punching.
Yes, but I would, again, it depends on how good you think you can use your calculator, and some of you aren't as good as you think you are with a calculator. So here's what I would do. I'm not trying to say that you're not good calculator people, but here's what I would do. I wouldn't even start with inverse sign. I would try to figure out what this fraction is first, and then plug that into the inverse sign. That's what I would do. So I'm going to type in 7 times the sine of 110 divided by 9, and that's what I'm getting. 0.7308720384. I haven't taken the inverse sign yet. That's what this fraction equals, 0.783, or 7308. You guys with me? Now I would plug this long decimal into the inverse sign. So now I'm going to do inverse sign. And rather than having to copy all of these decimals, 0.7308, there's an answer button on your calculator, and all it does is copy the previous answer. If you hit second and then the negative sign, it just copies the answer from above and puts it down where you want it. So it's 46.959. If we round up, it's 47. Now, technically, we should label this. This is an angle measure, so it's 47 degrees.
I know I'm asking a lot. Does the whole thing still have to be 180? I know I'm asking a lot, but again, you don't know if you really know this until you try one on your own. You may think you know by watching me, but all you know how to do is watch me do something. You've got to try it on your own. So I want you to do the A practice number. Sorry, number. Do the A practice number 6. Try that one. A practice number 6. And again, if the D's and E's and F's are bothering you, change them to A, B's, and C's. It makes it easy. It worked once. Like I did. We could be done. We got you checked out.
Yeah. So it was labeled with DEF, but you could change it to ABC if you wanted.
Could we make it X, Y, and Z?
If you want.
X, Y, Z.
But now we're looking for angle B. So I'm going to put sine B over little b. And we've been given angle C, so sine C over little c. And just fill it in. Sine B over 10 equals a sine of 96 over 18. Multiply both sides by 10. So sine of b is equal to 10 times the sine of 96 all over 18. Then do the inverse sine. So on your calculator, again, this is how I would do it. 10 times the sine of 96 divided by 18. Then take the inverse sine of that. I'm getting 33.5. All right, now we're done.
You